Hey there, you nines. Just following on from our last session on 8H, where I was introducing counting principles in factorial. Here's the previous video. If you haven't watched that, that was the first time I was introducing it. So that's what these notes are representing. In this video, I'm now going to do the examples to get you to get a feel of 8H. Remember, this is not examinable, but it is a topic I think is useful to learn, especially for next year, Year 10 Enhance. And I think out of all the probabilities, this is probably usually the more confusing one. So it's worthwhile having a look. So here in example 1, the following situations, they want you to decide if it's an addition or it's a multiplication principle in order to work out the number of choices you have. So let's have a look at A. Andy wishes to choose one book, okay, from a small library display, and then the display includes 8 paperback books and 5 hardcover books. So if you have a think about this, you've got a small library display. So let's say this is the display, right? In the small library display, it has 8 paperbacks. So let's say 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 of these paperbacks, okay? And there are 5 hardcover books. So I'm going to do hardcover, 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 hardcover. So you got 5 of these. Now, Andy wishes to choose one book. Okay, so only one book. So Andy is standing here saying, I'm going to choose, I'm going to choose one book. And when you're choosing one book, how many options? So find the total number of choices that Andy has. Because Andy's only choosing one book, Andy now has either 8 options from the paper book plus has 1, 2, 3, 4, 5 options from the hardcover book because he's only choosing one. So because he's choosing one from that shelf or the display, therefore there's only 13 options in total. Okay? Whereas if the question was to say one of a paper book or paperback and then one hardcover, then obviously you'd have now many possibilities from that point. In fact, it would have been 8 times 5, it would have been 40 possible options that he could have chosen one paperback and one hardcover. Okay, so yes, I know that the word says and, but looking at the scenario, can you see why this is an addition principle and not a multiplication principle? Okay. Next one. Andy wishes to choose one scarf. Okay, so one scarf from a group of 5 different scarves and then one hat. So this is another word and one hat from a group of 3 different hats. So this one's a different scenario. You see, this one is you had five different scarves. So 1, 2, 3, 4, 5. Scarf 1, scarf 2, scarf 3, scarf 4, scarf 5. Whoops, I drew too many. And so Annie chooses one of these. So he has to choose one. And we don't know which one, but there's obviously 5 options there. Then after they choose a scarf, they then choose a hat. So they could have got scarf 1, and then how many hats are there? There were 3 hats. So hat 1, hat 2, hat 3. So really the combination that Andy could have chosen was it could have been scarf number 1 and then hat number 1 because there are 3 different hats, right? Or it could have been scarf number 1, hat number 2, scarf number 1, hat number 3. That's 3 different combinations or 3 different ways that they could have chosen one scarf and one hat so far. So that means for every scarf chosen, so there were 5 of them here, for every one of those options they choose for the first one, there's another 3. There's 3 for every single option. So can you see how it actually ends up being 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, 5 groups of 3, which really just means 5 times 3. So essentially the mathematics, we say for every option in the first one, we then have 3 options for every 5, so therefore 5 groups of 3 or 3 groups of 5. Okay, and so this then gives you 15 total options. which then means it's a multiplication principle. Okay, so even though there is the word and in both, you kind of have to read the situation and figure out, well, logically, what am I really doing? How many options am I truly, really getting out? And that's the power that you're meant to think about in 8H. Okay? Scrolling down, so remember in this video, in the previous video, I talked about factorial. So the exclamation mark represents factorial. And if you put the number, say, 4 factorial, that just means 4 times 3 times 2 times 1. So you repeatedly multiply the one value below it. Okay? Let's have a look at some practices here. So when we say 3 factorial, this means 3 times 2 times 1, which actually gives us the answer of 6. Then we look at the next one. This is 5 factorial in the numerator. So 5 times 4 times 3 times 2 times 1. Divided by, in the denominator, we've got 3 factorial, so 3 times 2 times 1. Hopefully you realize now that because we're timesing, notice that it's 3 over 3, and then 2 over 2, and then 1 over 1. So it means you can actually write it as 5 times 4, so this is over 1 over 1, times 3 over 3, times 2 over 2, and times 1 over 1. So if you just times the numerator, you get exactly what you get in the top line over here. If you times the denominator, 1 times 1 times 3 times 2 times 1 is actually the same as 3 times 2 times 1. So what's nice about it is that these cancel out. 3 divided by 3 is 1, 2 divided by 2 is 1, 1 divided by 1 is 1. And so you naturally then end up with 5 times 4, because these values, which I'm just going to rub these out so you don't get confused, essentially these cancel out. So it's 5 times 4 left over, and that gives you 20. Alternatively, you can also kind of look at it as it's 5 times 4 times 3 factorial on the top, and on the bottom is 3 factorial, and we can see that 3 factorial divided by 3 factorial will cancel out to be 1, and then you end up with 5 times 4. Okay? And then lastly, we now have C, 4 factorial divided by 0 factorial, and that again is 4 times 3 times 2 times 1. But 0 factorial, remember our proof over here is actually 1. Okay, so it's actually equal to 1. Note 0 factorial equals 1, and I've shown you the proof there. So really, it's 4 times 3, which is 12. 12 times 2 is 24. Okay? Now, just to finish off today's lesson, a couple of nice things to think about. So you can work with numbers, but what happens if I gave you something like n factorial over n? What if I got you to do n minus 1 factorial divided by n minus 2 factorial? What does that end up with? Okay, so I want you to have a go with those two. See what you get. Pause the video. When you think you've got the answer, check it. And here we go. I'm going to go through the answer now. So n factorial means n times the number before it. So the number below it is n minus 1. Then you're going to do after n minus 1, you can then go the number below that one. So n minus 1 minus 1 again, which ends up being n minus 2, and then so forth, right? And on the bottom there, it's divided by n. So notice that when you're dividing, n divided by n cancels out, and so you actually end up with n minus 1 times n minus 2 times n minus 3, and it goes on, which we can just write as n minus 1 factorial. So that means when you take n factorial divided by n, you end up with n minus 1 factorial, which is the one I was trying to prove over here. Okay, so that's what I was trying to prove here. N factorial divided by n should actually be n minus 1 factorial. Okay? And then let's see what you get for the second one, assuming you've done it. Again, same idea. Notice this is equal to n minus 1, and then times by the number below it. So minus 1 again to it. So n minus 1 becomes n minus 2. Then you 1 below that one as well. So then it becomes n minus 3, and it goes on, right? Then you can see on the bottom, it's n minus 2 factorial, which means n minus 2 times the one below it is then n minus 3, because you're minusing 1 to it, and then n minus 4, and so forth. But hopefully you picked up a pattern here. Notice that Again, these two are the same, these two are the same, and it will infinitely be the same there. So what are you left with? You still have n minus 1. Okay? Another way to visualize this is it's n minus 1 multiplied to n minus 2 factorial, because we know it's going to be subtract 1, subtract 1, subtract 1, so you might as well recollect and write n minus 2 factorial, and the denominator is n minus 2 factorial as well. So you can see n minus 2 factorial divided by n minus 2 factorial will end up being 1. So the answer is n minus 1. Okay, so that's it for my notes for today. So those are the examples from my notes. Watch the two videos together before you have a go with exercise 8H. This is only if you're feeling pretty confident for the exam. Otherwise, utilize the time to start revising for your exam, which is in week 9. Next week on the Thursday. Okay, I'll stop the video here.